In this video, we're going to be talking about something a little bit different, and it's a step away from all the software. I want to talk a little bit about how wall framing works on a typical residential construction. So, one of the things that I get most feedback on is why don't we do concrete housing in the United States? And one of the things I want you to understand is because we have a lot of wood in abundance, and at the same time, wood has about the same flexural strength as concrete. Now, although it might seem odd that it be as strong as concrete, you have to understand how wood sways in the wind compares to concrete. Concrete failure is done by it actually exploding or it crumpling away. Steel bends to a certain degree and becomes stronger right before it fails. But when it comes to wood, it is quite flexible. Now, it does have its own disadvantages. It can burn rapidly. That has been a problem. It decays, termites, and things of that nature. And framing overall, it is a very tedious process. And since it's so tectonic, you have a lot of parts that come together. So any joint that causes issue can actually lead problem with wood. Now, we're going to be trying to cover as much about wood as possible when it comes to light frame construction, and then we want to get into how is a wall framed. So again, I have mentioned a lot of advantages. There's two types of framing that I want to talk about, and before we go into all the history, is balloon framing and platform framing. So balloon framing, if you can imagine, the wall itself, a two-story house construction, is continuous, and the wall and the floor itself hangs off of the actual balloon frame itself. So imagine this as a continuous stud. Now, the disadvantages of having a full length stud is that first, you need lumber that length. Second, we don't even grow wood at that size. And typically, lumber at that length is far more expensive than shorter members of wood stud. Now, I want you to also take into account the disadvantages of having such a long piece of lumber. It might seem stable, but you have to understand the fire hazard of the continuous stud. If one stud starts burning, there's no way to fireproof this cavity good enough where the fire can't just simply jump across from one floor to the other. So fire spreads much faster. No matter how much blocking you add, it won't be as sufficient as cutting the stud and then going with a different stud. Second disadvantage is putting it up. It is far more labor intensive to tilt a wall of that size. Now, when it compares that to a platform frame construction, you're looking at a sole plate that rests either on the foundation, and on this case, we have a pier and beam foundation, but even on slab on grade, you have your foundation, then you have your sole plate, top plate, a sole plate studs, and double top plate. The floor is completely cut. You have members that are girders, beams that are spanning across the shortest distance, and then you have your next member, or pretty much the floor continues exactly as it was doing on the first floor, goes to the second floor. Now, a lot of advantages, but the major one is that you have a fire stop. Now, the fire stop is what pretty much overtakes all of this, because if you have a fire in the kitchen on the downstairs and it spreads to upstairs, it takes a lot longer. Number two, you don't have to handle such a heavy load of a wall while putting up this wall. You can build it flat, then tilt it back up. And pretty much you're looking at 8 to 9 foot or even as high as 10 feet walls to be put up. A lot less labor intensive, faster to put up. The lumber itself is cheaper. So therefore, we use platform framing. Now, you can also make it far more sturdier by having a plates or all kinds of steel plate connections. But the biggest disadvantage you'll have is the overall vertical shrinkage of these houses, will technically shrink far more than a balloon frame construction, because you have to think about one piece of lumber shrinking versus all these multiple pieces of lumber. More surface area, the more moisture that can be lost, and of course there's going to be more settling. Now I'm going to go ahead and skip over some of these things. You can pause the slides and look at what I'm looking at, but this is just pretty much steps to getting to the frame construction. This is a photo of site and dugout, laying out the piping before we get into any type of a wall system being put into place. And this will be all covered under foundations. But typically when it comes to basements in South, you don't typically have basement because of the fact we have such a low water level. But you're using a bituminous layer, you're making sure it drains well, and you want to make sure your CMU drains, because if it doesn't, then you have a damp basement, right? You can do reinforced concrete on the ground slab, or you can do, as I was saying, pier and beam. Make sure you have a vapor barrier, 6 mil recommended, and it's not a vapor retarder, a complete vapor barrier before you pour in your concrete. Now, I'm going to go ahead and skip over all the foundation stuff and go ahead and go to the walls. Now, when it comes to floor framing, I want you to take into account the fact that floor framing is not what it used to be. Now we typically see these I-beam joists with OSB in the middle. That's what it is now. A lot of people envision this. It's not typically this. And at the same time, you can carve holes in this, and you can have a fur down even if you choose to create passageways for your HVAC. This is not typically seen anymore. This is far more expensive than trussing or even trussing with wood members. And this is what you see nowadays in the market. Again, these are what joist hangers look like. Bridging is pretty much used for flooring for it to not buckle. Your members don't have they don't have to lay flat on their side, right? The things that we think about: vertical loads, horizontal loads, and pretty much dead load, live load. Now, when I'm going to go ahead and switch my PowerPoint to the next slide, and this is where we get into what are the framing members that we're looking at. So what we're looking at as framing members are such as follows, right? You have a 1x4 bracing that goes all the way across to keep the wall from not racking, right? Obviously, the most typical things that you will have is the stud. Studs in the United States after 1980s are 16-inch on center, and this allows for a complete 4-foot board to fit on there. And the reason we do 16 is because you'll have 4 studs that will be able to catch the drywall sheet. Now, again, your drywall sheets are 4 feet by 8 feet. So that's why studs are 16-inch on center. Prior to that, they were 2 feet on center, and 3 studs would catch an entire plywood sheet. Now, the next thing I want you to take into account is there's a sole plate. This is a weather-treated piece of lumber that is placed on the floor, and it is in direct contact with concrete. Now, if you have a high-end home, you might end up having a neoprene pad or a soundproofing or some sort of flashing that will go between there. But most of the time, because it is weather treated and it will eventually have a facade or skin, siding, brick, whatever you want to call it, on top of it, you can typically have the stud rest directly on top of concrete. Plus, you have to make sure that that concrete has vapor barrier underneath it. The next thing I want you to understand is, let's look at this door framing right here. So on top of this sole stud, you have what's called a jack stud or a trimmer stud. On site, most people will call this the jack stud. What you have going on here is this is what supports the header. Header comprises of 2 2x and a piece of plywood that goes down the middle. That makes your 3.5-inch width. So if you can imagine a 1.5-inch piece of lumber on its side plus 1.5-inch, which is 3 inches, and you put a 1/2-inch board in between, nail them, and you can put them as headers. The rule of thumb for headers is for every foot of span, you need to have 1 inch in header. So for example, you have a 12-foot opening. Let's say you have a 12-foot opening between this header. You need a 2x12. That's simply the easiest way to remember it. Now, you have your jack stud, you have your header. Right next to your jack stud is the king stud. This stabilizes it. I want you to take into account that king stud might be an additional stud that is added. Make sure you keep your 16-inch on center because you want that drywall to catch something. And then whenever you have an opening, you can add an additional stud where you're going to end up having a king stud. Now, what I want you to understand is it's always better to have more studs than less. Now, I know there are people who are talking about efficiencies. You want to make sure that your king stud ends up being one of the studs that are going to be on 4 foot on center. But what I say is it's better to be structurally stable than to have a little bit less R values in your wall, and that's the insulation. So you have your jack stud, king stud, header, 16-inch on center. You have your 1/4-inch brace. Go into the window. Same situation here. You have your cripple studs that are still 16-inch on center that goes across the top of headers, on top of windows, as well as the bottom of windows. Now these studs are specifically just for drywall. They're just trying to catch the drywall. You have to understand how forcers work. So the load on this window comes through this wall, comes through the cripple stud, which is still 16 inches on center, diverts through the header, hits the jack stud, king stud, go all the way down, hits the sole plate. These cripple studs underneath the window are doing absolutely nothing but catching drywall. It's holding nothing but the window. The window itself is not supporting weight, and if it does, you will have a crack through the glass if it does that, or you will have problems with it opening and closing. So those are your typical members. Now, when it comes to your top plate, they're always double top plate, and you have a 4-foot overlap wherever you splice. Now, this is to ensure you have good contact. And the reason we keep it double top plate is because if you look at a corner joint on a wall, you want them to overlap in this manner. The reason is it keeps the wall from racking, and at the same time you get a much truer corner despite this bad nail job. Now, with that said, this concludes how to build a framing wall. Please like, subscribe, and comment below.